Hey guys, I'm Kavin. This is Shakti, and this is Jay. Actually, we are new to the quantum computing. Yeah, actually, we are the fallen soldiers of the learning group. We survived till the visas came. Yeah, actually, these guys survived till 5 p.m. But yeah, so since we are very new to this quantum computing and all this learning helped, and we were like, I was a bit curious on comparing like this. Can all the classic algorithms can be done with the quantum computing? So basically, that's our project. So what we have done is like we are taking all the classic algorithms and giving it to the chatbot, to the RAG model, and checking whether this classic we are identifying the bottlenecks in the classic algorithm and mapping this bottlenecks to the known known quantum algorithms. So that is what we have done here. So what I have done basically here is like find a number in the unstructured list. So it gets the LeetCode problem out of it and gives a classic solution. And yeah, it gives a verdict as well. Like it checks whether it be done better with the quantum computing, or is it possible? Is it a possible advantage, or is it a possible disadvantage? Like it cannot be done with the quantum computing and unknown. Three verdicts, and it will also map the algorithm which could give a better which could be optimize the classic algorithm. Here it says the Grover search algorithm could be better in this case, and it also has a side by side comparisons, and I explain it's like I'm 10. So that's our project basically, and yeah, and we were also uh, read a few things about the Grover algorithm. How do we, yeah, come on, how do we switch tabs? Okay. So yeah, actually we have created a interactive game to better understand the Grover algorithm. So there is a pizza in one of these boxes, but this is the classical search approach, and this is the Grover algorithm. So in the classical search approach, what we have to do is we have to open each and every boxes. We'll have the finder function, and we'll have to open each and every boxes, and it will return whether this has a pizza or not each and every time. So it's a O of n problem. And in Grover's algorithm, what it basically does is like the previous team explained, it has a oracle and a diffusion. So the oracle, what it does is like it flips the sign of the vector for that one right box alone, and leaves the other box untouched. And when the diffusion, when with the interference, the probability of the right box increases and the other boxes decreases over the number of iterations. Like you could see here, it takes a lot of time to find. Yeah, we found the box in the seventh attempt, but in Grover's algorithm, you could search it with in the first iteration. It gives like 47% in this box. In second iteration, it's like 90%. In third iteration, yeah, it gives the correct approach. Like in the O of square root of n time complexity. So yeah, that's our project.
And for like what I understood, like once it crosses beyond root of n, and when it crosses the highest number of iterations, what happens is it overclocks the iterate. So here it is not, the amplitude doesn't increase linearly, whereas like in a normal circuit it doesn't increase linearly, and here the iterations is based on the bit flips. So even after let's say the third iteration, during the fourth iteration it just goes beyond the actual probabilistic value. So when it goes beyond that, the overall mean of all the of all the uh, superpositions increases, the overall mean increases, and it's basically like an overlook or an overkill. So when it goes, so only until the, let's say, root of nth iteration, we get the maximum possible probability, and when it goes beyond that, it flips is what like we have understood with the Grover's algorithm.
So is it imitation of the simulation or in the real quantum experiments?
I'm not sure how it happens when we check, like when we were iterating the same thing, the probably values were the individualistic amplitude, it started decreasing after that nth iteration, and the overall mean started to increase. So when we checked regarding that, this was given as the reason. So when it goes beyond the nth iteration, then it starts to move away from the point.
Do you guys understand? Like, I also had a question on some grade. Like, if the oracle reads the face, like the sign of the face, the state, can't we just like measure the sign of the face in a single operation and say that the only one is negative in the pattern? Like, why can't we do that?
I don't think we can pass in between the iterations and check which has the better value.
Because
I guess.
the oracle, it was like mentioned as a black box, and only after the iterations are done, the amplitudes are being given out. So like internally, what's happening, we're like not sure of the entire thing. What's actually happening in that.
Let's chat about it.
Yeah.
And yeah, this was all like whatever we were able to find it out. It was all from the learning group. So shout out for the learning group.
Nice. I like the side-by-side comparison, because often I'm like, why? Everyone's asking, like, how do I see the speed up? And
Yeah.
something like that really gives you a good visual. That's nice.
Thank you.